Welcome to this explainer. Today we're diving into a topic you've probably heard about a million times, but we're going to reframe it completely. We're looking at global warming, the invisible crisis reshaping our world. Drawing directly from the rigorous insights of Dr. Arun's sustainable engineering lectures, this explainer is designed to take us from just basic awareness right up to technical mastery. We aren't just going to look at the problems today, we're going to break them down with crystal clear, academic precision, treating them as the ultimate engineering and design challenges of our time. So let's jump right in. Here's our roadmap for today. We'll start with the invisible crisis, unpack the greenhouse effect, look at what's driving climate change, and explore a world under stress. Then we'll tackle the engineering challenge, and finally, look at how we build a resilient future. All right, part one, the invisible crisis. When you hear the words global warming, you probably instantly picture that tragic image of a lone polar bear stranded on a melting piece of ice, right? Well, Dr. Arun demands a total paradigm shift from us. To quote him directly, I want you to see not just a sad animal, but an engineering problem, a design challenge, and a crisis that is already reshaping the world you will build. That's our baseline for today. We're moving past passive observation. You're here to be armed with knowledge as future problem solvers. The infrastructure of tomorrow literally requires an entirely new blueprint, and creating that starts with understanding the science today. Moving on to part two, the greenhouse effect explained. Let's make sure we're all perfectly clear on our definitions before we get too deep. When we say global warming, we are talking about the unusually rapid increase in Earth's average surface temperature over the past century, primarily driven by human activity. It's the key, measurable protagonist in the broader story of climate change. We're talking about a highly accelerated shift in thermal dynamics on a massive planetary scale. Now, the natural greenhouse effect is actually a good thing. Sunlight enters the atmosphere, warms the surface, and some of that heat gets trapped. That process is absolutely essential to keep Earth from turning into a giant frozen ball of ice. But the human amplified effect, that totally changes the equation. Think of a car parked out in the hot summer sun. Sunlight passes through the windows, heating up the inside, but that heat can't easily escape. Gases like carbon dioxide and methane act exactly like those car windows. By burning fossil fuels, we've effectively made our atmospheric window thicker, and that's trapping unprecedented amounts of excess heat. And that brings us to a highly specific and absolutely vital number, 1.44 degrees Celsius. That is exactly how much warmer the global average temperature is today compared to the late 1800s. Now, you might be thinking, a degree and a half? That sounds pretty trivial. But let's put that into perspective. The last ice age was only about 4 degrees Celsius cooler than today. Just let that sink in for a second. Just 4 degrees separates our current comfortable climate from a literal ice age. That proves that a shift of just 1 or 2 degrees makes a massive destabilizing difference. The rate of change we're measuring right now is truly unprecedented in the last 2,000 years. Which brings us to part 3, drivers of climate change. The impacts are already staggering. We are losing an estimated 500 billion work hours globally every single year due to severe heat stress. And the primary driver behind this? Greenhouse gas emissions. Our modern lifestyle comes with a massive hidden carbon price tag. We've got the burning of fossil fuels for our electricity and heat, heavily oil-reliant transportation systems, and rampant deforestation. Forests are critical carbon sinks that naturally absorb CO2. So cutting them down doesn't just release stored carbon, it actually destroys our planet's natural filtration system. On top of that, agriculture and certain industrial processes release incredibly potent gases, like methane. Ultimately, this is the collective price we're paying for modern convenience. Part 4. A world under stress. Let's survey the global impact, starting with melting ice and rising seas. Both the Arctic and Antarctic are heating up way faster than the global average. This is shrinking ice caps and totally throwing off marine food webs. But listen, this isn't just an ecological issue. It is a profound human one. All that melting ice flows right into our oceans, pushing sea levels up. Right now, in the Sundarbans, that vast, beautiful mangrove ecosystem shared by India and Bangladesh, rising waters have already swallowed low-lying islands, displacing thousands of people. The literal map of our coastlines is being redrawn as we speak. Moving inland, we face the immense threat of disappearing glaciers. Think of the Himalayas as the literal water towers for the entire Indian subcontinent. As temperatures rise on the Tibetan Plateau, these glaciers are retreating at an alarming rate. This poses a critical long-term threat to the water supply that millions rely on for drinking, agriculture, and hydropower. Plus, melting permafrost severely destabilizes mountain slopes. That leads to incredibly dangerous geohazards like massive landslides and catastrophic events known as glacial lake outburst floods. Now, dip beneath the surface of the ocean, and the numbers are just jaw-dropping. 97%. That is the amount of coral lost in a single northern section of the Great Barrier Reef during recent severe marine heat waves. Corals are highly, highly sensitive to temperature. When they get stressed by the heat, they bleach and they die. We're talking about the collapse of an ecosystem that supports a quarter of all marine life. It is the ultimate canary in the coal mine for our oceans. Back on land, our food systems are under intense pressure. For many major crops, once temperatures push past 30 degrees Celsius, yields start dropping off a cliff. Just look at the projections under a 2-degree warming scenario. We're talking massive crop yield losses. 46% for wheat, 31% for maize, and 19% for rice. And to make matters worse, warmer temperatures allow destructive pests to expand into new territories. To protect global food security, we desperately need to engineer heat-resilient crops and rethink our entire agricultural timeline. But it isn't just our future food or our coastlines at risk, it's our past. 80%. According to a recent study, 80% of UNESCO World Heritage Sites are already facing severe climate stress. Our shared cultural history is quite literally under attack by the elements. This threat is incredibly diverse, too. Take the 4,000-year-old ziggurat of Ur in Iraq. It's crumbling because shifting sand dunes and rising salty groundwater are eroding its ancient mud bricks. The iconic Moai statues of Easter Island, they face the very real threat of just being submerged by sea level rise. The stunning ancient mosques of Esfahan in Iran are literally being torn apart by land subsidence linked to severe drought. And way up in the far north, an Arctic whaler's graveyard, a totally unique 17th century archaeological archive, is washing away due to thawing permafrost and coastal erosion. The physical records of human history are crumbling, drowning, or cracking apart right in front of us. All right, part 5, the engineering challenge. So we've assessed the damage. Now we pivot. We shift our focus to the specific technical interventions required to actually adapt and overcome. The harsh reality is that our current infrastructure was designed for a climate that simply no longer exists. This is our call to action. We need to step up across 5 core disciplines. Step 1, coastal engineering. We've got to design advanced seawalls and utilize nature-based solutions, like restoring mangroves, to fight back against rising seas. Step 2, water resources management. As those glaciers retreat, we need entirely new systems for water conservation and storage. Step 3, urban planning. Our cities must become heat resilient, using cool roofs and advanced ventilation strategies. Step 4, foundations and geotechnics. Engineers have to calculate for melting permafrost to ensure ground structures remain stable. And finally, step 5, sustainable materials. We have to innovate way beyond carbon-heavy cement and steel to radically reduce the carbon footprint of how we actually build things. Finally, part 6, building a resilient future. Let's wrap this up with the core takeaways from today's explainer. First, global warming is unequivocally a human-driven phenomenon. It is mathematically measurable, and it is accelerating. Second, it's triggering a massive cascade of physical changes all over the globe, from the deepest oceans to the highest mountain peaks. But most importantly, these are no longer just environmental talking points. They are hard, technical engineering problems. And it's the next generation of engineers, architects, and informed citizens who are going to design the solutions. You are not just passive observers in this crisis. You are the architects of a resilient future. I want to leave you with one final provocative challenge from Dr. Arun. Tomorrow, when you walk outside and look at a building, a road, or a bridge, I want you to look at it critically and ask yourself, how was this built for a different climate? Consider what would happen to it during an unprecedented flood, a multi-week heat wave, or a severe drought. Start analyzing the world around you, because understanding the flaws in yesterday's designs is the very first step in engineering tomorrow's survival. Thank you so much for joining me on this explainer, and keep questioning the world around you.